Okay, sorry. All right, so we've got the center. That should be pretty simple, right? Eyeball it. We know that the distance from the center to either vertex is our A value, but that's not the number you put in the equation. So make sure that you put the squared version of the equation in there. And again, it goes under x squared because of the way that the ellipse is drawn. It's longer horizontally, okay? So then the distance from the center to the covertex, that's my B value, so I can see that that's 3. Again, square that number to put it into the equation, and now you have your equations. Okay? I'm not going to do all the other parts since we just talked about that in the warm-up. So just want to make sure we practice writing the equations, okay? Any questions on that? Good so far? Okay, now looking at this equation, looking at number 2, I can see that this ellipse is oriented vertically. Okay, so find the center. If you're unsure, make sure it's equal on both sides of the center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so my center is 1, 2, 3. Oops. And 1, 2, 3, -2. Okay, so I start writing my equation by putting my center in. X minus 3 squared plus y plus 2 squared always equals 1. Okay, again, A is the distance from the center to one of the vertices, so A is 5, but this time it goes under y squared to show that it is a vertical ellipse. B is 2 units, square that value, and there's your equation. Okay? Not bad, right? That's the easy part. Okay? So let's jump down here. I'm going to do a couple of these. It gives you a couple reminders. Find the center using the midpoint formula of the vertices. Co-vertices are the focus. Use the vertices to find A, use the co-vertices to find B. If given the foci, use the formula that relates A, B, and C to find the missing part. Okay, and then you'll determine the direction based on the vertices, co-vertices, or the foci. Okay, so for instance, I know that my ellipse, because I'm looking at this and I see that these are the 2 numbers that are changing in the vertices, which means that my ellipse is going like this, which means that the A squared value will be under X. Okay, so I'm going to find the middle. So I know, my center, I know one of the coordinates is going to be -2. The other coordinate is the middle of these 2 points. So 5 plus -19 divided by 2 is -14 divided by 2 is -7. That is my X coordinate of my center. Everything is happening from the center, so you need the center point first. So if I wanted to, I could start writing my equation, right? X plus 7 squared, y plus 2 squared equals 1. All over, oh, what the heck? Okay, now A is the distance from the center to the vertice. So A is the distance from -7 to 5. So what is the distance from -7 to 5? How many units? 12. Now that's my A value, so I square that and I put it underneath X squared. Again, why did I do that? Because I determined at the beginning that this was the direction of my ellipse. Okay. Then it gives me the length of the major axes. I know that I get the length of the major axes by doubling my B value. So I'm going to set that equal to 10. I know that B is 5. However you want to do this, you're cutting, anytime you want to find the A or B value given the axis length, just cut it in half. Okay? And then I square that number and I put it underneath the y squared and I'm done. Okay, did I go too fast? Questions? So far, so good? Or we're not sure? Okay, let's try another one. I'm going to do 7. There's a lot of examples here. So I'm not going to do all of them. All right, so first of all, we need a center. Okay, so that should be the first thing you look for. You could either find the middle of the foci or the middle of the vertices. Doesn't matter. Okay, I'm going to go ahead and just use the vertices since they're on top. I look at this time and I say, oh, what's changing is the y coordinate, which means that my ellipse is vertical. I know that the center is going to be 5 comma something because it's got to have the same x coordinate as the vertex and focus point. So I take 11 plus negative 15, divide that in half. That's negative 4 divided by 2. So the y coordinate is negative 2 of my center. And I start writing the equation. The distance from the vertex to the center, the coordinate that's changing is 11 to negative 2. So that's my A value. So what's A equal to? Anyone going to share or what's happening right now? How many units apart are 11 and negative 2? Is this a complicated question? 13. Yes, Lucas, thank you. 13, right? Okay, now we have to be careful. We agreed this ellipse was vertical, so the squared version of A has to go underneath the y. Now, we do not have anything about B in this problem, but we do have something about C because C comes from the focus. So I want to know my C value so I can use that equation. So again, I need to know what's the distance from 10 to negative 2. 12. It should be less than A. Okay, and then there's an equation that relates them, right? So C squared equals A squared minus B squared. So 144 equals 169 minus B squared, right? And then you're going to solve for B squared. Okay, you don't necessarily need to show me that you're dividing by negative 1. Just don't put a negative B squared value into your equation. Okay, I don't need to know what B is. I need to know what B squared is. That's what I need for my equation. So you don't need to tell me that B is 5 or whatever, okay? Because I'm writing the equation, so I'm done. B squared is 25. That's what goes in the equation. Okay? All right, so you have 2 lesson checks to complete.